All right, in this example, we are given the mass percentages of a compound, in this case, vitamin C, and we want to determine what is the empirical formula. Now, an empirical formula, by definition, tells us what is the ratios of the atoms of each element in that compound. Not only does it tell us about the atoms, but it also tells us about the moles. So an empirical formula also tells us the ratio of the moles of each element in the compound. So the easiest way to solve these problems is to assume that we have 100 grams of this compound. The reason we pick 100 grams is because then it makes our next step easier. Right? If I have 100 grams total, then that means I have 40.9 grams of carbon, I have 4.58 grams of hydrogen, and 54.5 grams of oxygen. And so because the empirical formula is the ratio of the moles, I then want to get those masses into moles. And so to do that, I'll divide the mass of carbon by its molar mass. So I've got 40.9 grams of carbon divided by its molar mass from the periodic table, 12.01 grams per mole. And so that gives me 3.41 moles of carbon. And I'll do the same thing for the hydrogen and oxygen. So I have 4.58 grams of hydrogen divided by its molar mass. And then oxygen. All right. Now, an empirical formula is a mole ratio. And so a ratio means I've got to divide. And so what we're going to do is we're going to look at each of the elements in our compound and see which one has the smallest number of moles in that compound. And so carbon has 3.41 moles and oxygen has 3.41 moles. So these two are tied for the smallest. So the empirical formula is the smallest whole number ratio. So if I divide all of the elements by 3.41 moles, these guys will come out to be 1. Right? And so we want the smallest number ratio, so the element that I have the least of should have a 1. So I'll take carbon, 3.41, divided by 3.41 is just 1. And oxygen is the same, right? 3.41 over 3.41. I have the subscript of the oxygen and the carbon is both going to be 1. When I do this for hydrogen, I get 1.33, right? So in principle, we now have the empirical formula. I have 1 carbon, I have hydrogen 1.33, and oxygen I have 1. Now, of course, you can see what the problem is here. When we write the empirical formulas, we don't like having fractions. And so what we need to do is multiply the whole formula, so the carbon, the hydrogen, the oxygen, by the smallest whole number that makes everything have whole numbers, right? And so, for example, if I had 4.25, that would be 4 1/4. The easiest way to turn a quarter into something whole is to multiply it by 4. If I had 2.5, right, 0.5 means a half, so I'd multiply it by 2. In this case, I have 1.33, right, so that's 1 1/3. So I want to multiply all of the elements by 3. And so 1 times 3 is just 3. So I've got C3. 1.33 times 3 is 4. So I've got C3H4O3. Right, so what I did is I multiplied each of the subscripts by 3 so that I could get everything in whole numbers. And so this is the smallest whole number ratio of the elements in the compound. And this is our empirical formula.